Cast irons are classified depending upon the nature, shape, size, and distribution of carbon and presence of other elements. One such classification is grey cast iron. Now coming to the composition of grey cast iron. Grey cast iron contains carbon and silicon, and in that carbon in the range 2.5 to 3.5 percentage and silicon in the range 1 to 2.8 percentage. Also, there may be also a presence of elements like manganese, sulfur, and phosphorus. The carbon in grey cast iron exists in the free form as graphite flakes embedded in a matrix of ferrite or pearlite. Now coming to the properties and uses of grey cast iron. One of the main properties is that it is having low strength and brittle in tension. This is due to its microstructure. It is also to be noted that the strength and ductility of grey cast iron are much higher under compressive loads. The grey cast ions are comparatively weak and brittle in tension, like I said, due to its microstructure. The graphite flakes have tips which serve as points of stress concentration. Now, another important properties of grey cast iron include low melting point, good fluidity, good castability, good machinability, good wear resistance, and low impact strength, making it one of the most used cast irons. It is also to be noted that the cost of production is lowest among cast irons. Hence, like I said, it is the most widely used type of cast iron. Some of the applications of grey cast iron include automobile parts like cylinder block, cylinder head, brake drum lining, household appliances, gearboxes, etc. etc.
I am here to explain the detailed study of nodular cast iron, or it is also known as ductile cast iron. Here we can see the microstructure of nodular cast iron. When the microstructure of the cast iron consists of nodules or spheroids of graphites in terms of the pearlite or ferritic matrix, so the resulting materials is called as nodular cast iron. So the nodular cast iron is the improved version of grey cast iron with a greater toughness. Next we are discussing the chemical composition of ductile cast iron. Just we can see that the carbon content is 3.2 to 4.1 percentage, silicon content is 1.1 percentage to 3.5 percentage, magnesium 0.3 to 0.8 percentage, phosphorus 0.08 percentage, and sulfur 0.2 percentage. And also it contains nickel as an alloying element. So these are the chemical composition found in the ductile cast iron. Basically, the presence of this nickel and magnesium that will have a major role to the formation of graphite nodules. That way it will be making a nodular structure as the microstructure of nodular cast iron. Now we will discussing the different kinds of properties is being present for ductile cast iron. First, as per the name, it is having very good ductility. Due to higher ductility, it will having good tensile strength, about 38 kg per millimeter square to 80 kg per mm square, and also superior, and also it have good wear resistance as well as shock resistance. Due to this good wear resistance and shock resistance, and also have it has good strength, so these properties, the nodular cast iron is widely used as metalworking rods, and it also used for crankshaft, so it is also used for agriculture implementation.
Good evening, my name is Harsh. I'll be explaining about white cast iron. There are many types of irons or many types of cast irons used in the industry, each having specific characteristics and applications. The most common abrasion-resistant ferrous material having carbon greater than 2% in the form of cementite is called white cast iron. White, fisted, fracture due to presence of cementite is the main characteristic of white cast iron. I'll be telling you about two different types of cast iron, white cast iron. Low alloy iron and high alloy iron. This is also low alloy iron. This is also called pearlitic white cast iron. It has relatively fast cooling. It is possible to prevent the nucleation of carbon flakes. And high alloy cast iron is commonly termed as white cast irons having content greater than 4%. The casting of such ferrous material is carried out for high abrasion resistance material like parts needed in machinery that are used for industrial use such as cutting and grinding. Is white cast iron wieldable? White cast iron contains a strong continuous network of carbides that are difficult to wield. Wielding is normally not recommended with white cast iron as the structure does not allow so. The combination of carbides in various hard matrix phases is prone to heat cracking. Wielding and immediate cooling result in cracks in the cast iron. That is why white cast iron is not recommended for wielding. How is white cast iron produced? Most commonly, white cast iron is produced by casting technology. Other manufacturing methods involve mechanical working since cast iron is extremely hard and brittle. The only possible way to shape white cast iron is to cast material in certain shape. Certain applications of white cast iron are dredge plumbing, oil and sand applications, mining crushing parts, ball mill liners, roller crusher liners, grit blasting grates, and lifting bars. Thank you. That's all about white cast iron.
So, good evening all. I am Rishiyesh Narayanan and I am presenting before you my topic malleable iron. So, now let us look at the processing of malleable iron. Malleable iron castings are produced from white iron castings using a heat treatment process known as mallebalizing. So, now we can see what the mallebalizing process. In this process, the white iron is heated above 700 degrees Celsius and it is held at this temperature at a longer period of time and then cooled. So as you can see, the white iron is heated above 700 degrees Celsius and it is held there for a long period of time and then finally cooled. During this process, cementite in white iron decomposes into graphite carbon in the shape of irregular shaped globules or rosettes. So this is what happens during this process. And the matrix is either pearlite or ferrite depending on the cooling rate. Malleable iron contains graphite nodules that are not truly spherical as they are in ductile iron because they are formed as a result of heat treatment rather than forming during cooling from the melt. So this is because they are cooled after a long time of heating. Now let us look at the properties. So malleable cast iron possesses a good combination of physical, mechanical and engineering properties. So due to these, they find a very wide applications in many industries. So its properties are it is having high strength compared to white grey cast iron. Then it is having better vibration, then better wear resistance, and also malleable cast iron is not brittle as grey or white irons. Then it has got good ductility. Malleable cast iron is 580 megapascal. So now as you can see the image, this is polycrystalline structure of malleable iron viewed in a microscope. Due to the previously mentioned engineering, mechanical and electrical properties, malleable iron castings are widely used in the automobile, electrical and railway industries due to good combination of properties such as strength, ductility, wear resistance and machinability. Ferritic malleable cast iron is used in the annealed condition for general engineering applications, and also the pearlitic malleable iron cast is used in as cast condition for the above same purpose. Following a quench and temper treatment, the martensitic malleable cast iron can be used for connecting roads. So this we can find in the many pipelines and also in many electrical industries. It's also found in engines in automobiles. Then it is often used for small castings requiring good tensile strength and the ability to flex without breaking. So it is due to the ductility. That's the main property behind this application. Also another application is that its uses include electrical fittings, hand tools, pipe fittings, washers, brackets, then fence fittings, then power line hardware, farm equipment and also other machine parts. So now you can see the image, then the malleable iron parts actually used in the sanitary fittings, then also other machine parts, tools. So as you can see, malleable iron is actually used in almost every field of engineering, and we also find a lot of application for this due to its great properties. So that's all. Thank you.
Today we are going to discuss about the classification of cast iron. The first classification we are going to discuss is about wrought irons. Wrought iron is an iron alloy with a very low carbon content in comparison to steel and impregnated with tiny fibrous inclusions of iron silicate known as slag. The presence of slag changes the chemical properties of the iron enough to create a new and beneficial metal. Wrought iron is a confusing term that refers to both a type of metal and a process of formation. It is having good strength under tensile pressure, resistance to corrosion, and is having malleability. Upon rusting, wrought iron distributes the rust into beautiful brownish finish and keeps a good finish. Wrought iron lacks the carbon content necessary for hardening through heat treatment, and this is the reason why it is no longer used on a commercial scale. Some of the uses of wrought irons are: it is used in decorative items such as railings, outdoor stairs, fences, and gates. It's used as nuts and bolts and also used in handrails. The next type of iron is alloy cast irons. These are casting alloys based on iron carbon silicon system that contains one or more alloying elements added intentionally to enhance its properties. One such example is nickel resist with 20% of nickel and 2% of chromium, and another example is nickel hard, which has a composition of 4% nickel and 1.5% chromium. This alloy cast has an excellent corrosion resistance and heat resistance. Some of the uses of alloy cast irons are: it's used as cement concretes and is used in mining industries due to its high wear resistance. Thank you.